Okay, fine. So I was explaining about the standard deviation calculation methodology and how to infer the standard deviation, where the thumb rule is lesser the standard deviation, it better is the performance of the overall students, as an example in this case. Or if you have any other data of a business or a process, you can then take a call in terms of finding out where we are in terms of standard deviation. Standard deviation basically indicates the precision of the process. Okay, what is precision? That it is about how accurately again and again we are able to repeat the similar performance, right? So lesser the standard deviation, precise is the performance. That is how we infer the data. Okay, then comes the recap. What we have learned so far. Okay, first we saw what do we mean by quantitative data, what is qualitative data, and why we don't take qualitative data in Six Sigma. Then we went into continuous data, that is data which can be measured, like height, weight, distance, temperature, etc. Within continuous data, we saw measures of center and measures of spread, where in measures of center, we understood what is mean, which is also known as average, what is median, which is also known as the mid value of a data set. Mode is the number of times a data occurs in a given data set. Then we saw what is range, that is highest value minus the lowest value. And then we saw standard deviation, which is a measure that talks about the precision of a given data set or a given process or a business. Okay, so all this what we covered relates to the continuous data. And I said in quantitative we have something called as discrete data as well. So over the next few minutes I am going to talk about the discrete data, the data which cannot be measured but can be counted, is what we will be talking about in the form of discrete data. We have already finished the break, so let's quickly get into the discrete data now. Okay, discrete data, the definition is very simple and straightforward. It is that data which can be counted. Simple, which can be counted. Example, number of students in the class, percentage of marks scored by the students, etc. Some of the simple but easily to understand examples of discrete data, right? Now, discrete data can be divided from a Six Sigma measurement standpoint into two categories: defects and defectives. Defects and defectives. And defect is a word which we use in general on a daily basis. Sometimes we say my mobile phone has a defect, internet connection has a defect, or my scooter has a defect, it's not starting, there is some starting trouble, looks like some part has a defect, right? It's a very generic term that we use on a day-to-day basis. And based on this term defect, three types of measures have originated in the world of Six Sigma. See, before we get into each of these terms, we need to understand that the history of Six Sigma, right? Six Sigma as a concept was originated in Motorola for their manufacturing process. Essentially, the journey of Six Sigma started in the world of manufacturing. Over a period of time, towards the end of last millennium, people started to discover that apart from manufacturing, Six Sigma as a concept, as a problem-solving methodology can be applied even in service industry, education, hospitality, healthcare. You name the sector, it can be applied. And people who experimented with the concepts of Six Sigma were successful in applying it in those areas. For example, myself, I am not an engineer by academic. Okay, I have never worked in any manufacturing setup. All my experience has been in service industry, banking operations, retail supply chain, corporate IT for HR and finance, and now in HR, core HR function. All of my 15 years of experience has been in service industry, but I haven't found an area or an opportunity where Six Sigma could not be applied. Okay, so therefore, what you are going to see now in the form of discrete data, essentially the concepts originated in manufacturing environment, but its applicability in other areas is equally possible. Okay, so coming back to the topic, defects. Defects can be measured in three major ways: defects per unit, defects per opportunity, and defects per million opportunity. In fact, the soul of Six Sigma lies here, per million opportunity. Okay, why and how, we will talk about it in a short while. So first we'll cover defects, under which we will first talk about defects per unit, then defects per opportunity, and finally defects per million opportunities. Okay, let's get into the next slide. First, let's try to understand what is defect and defectives. In the previous slide, you saw one box which read as defective, right? So let's first understand the meaning of these two terms. The term defect means a shortcoming or imperfection in a product or service that has been delivered. Something that the customer expected but did not turn out to be there, or a shortcoming because of which the customer is unhappy. That is what we call as defect. For example, Pizza Hut and Domino's Pizza, they have a delivery promise saying within 3 kilometers of their unit, they will deliver the order within 30 minutes, right? That's a brand promise that they carry with them. And that is what even the customer will expect. So if instead of taking 30 minutes, if the pizza is coming, say, in 45 minutes or 1 hour or more than 1 hour, obviously the customer will be unhappy, right? Because the brand promise was missed. The business failed to give that pizza within 30 minutes. So such unhappiness of a customer is called as defect by the business provider, the service provider, because they have failed to meet that promise. There is an imperfection. That is basically known as defect. Even in your, say, mobile phone that you buy, within 2 or 3 months, you feel that the battery is getting drained out very soon, and it requires 4, 6, 7 hours to get charged. You will say the battery has some defect. Something is wrong with the battery. It's not meeting my purpose. I'm unhappy with that mobile handset. It could be of any company: Motorola, Nokia, Samsung, Apple, whatever you take. Right? So that is that shortcoming which is not satisfying your requirement is known as defect. You are not liking that product because of that defect. In this example, the battery strength, right? That is known as defect in general. If a product or service has one or more defects in it, then such a product is called as a defective product. In that mobile example, because the battery is not working properly, that phone is called as a defective phone. Why? Because the battery is poor. It is also possible that the screen is not good. It is also possible that the panel is very weak. The plastic of the panel is very of poor quality. All those are defects. But if a product has one or more defects in it, it is called as a defective product. One or more defects means it is a defective product. Let's look at an example here and try to understand what is a defect and how it is different from a defective product or a service. We have about 11 cups, coffee cups, that we use almost on a daily basis, right, to drink tea, coffee, etc. Do you see some cross marks in purple color? What is it indicating? It is telling that in some cups, the handle and the top portion of the cup is broken. In few cups, the handle, the top and the base of the cup is broken. And there are some cups where everything is fine, right? There are 11 cups, and in some cups, some or the other thing is broken and the remaining cups are perfectly fine to use. Now, what will happen if the handle is broken? You obviously cannot hold the handle of the cup and have your favorite drink, tea, coffee, milk, whatever you have. What will happen if the top portion of the cup is broken? It will hurt when you are trying to sip the drink, right? What will happen if the bottom portion of the cup is broken? The cup will not stand properly on the table where you are placing it, and obviously it will fall, right? So those are nothing but the defects in that product, defects in that cup. And in some cases, there is only the base is broken. In some cases, the handle and the top portion is broken. And in some of the cases, the handle, the top and the bottom portion, all three are broken, which makes that cup a defective product or a defective cup. So when a product has one or more defects in it, it becomes a defective product. In this case, defective cup. Let's try to look at some questions and make our concept of defectives even more stronger now. The first question is, how many cups are there in this set? How many are there? We have about 11 cups. If you count from left to right, you will get 11 cups. In total, how many defects are there in this lot of cups? As I said, what is defect earlier? How many defects are there totally? So if you count the number of X's, right? Cup 1, 2, cup 2 is fine. Cup 3, there are 3 defects. So 3 plus 2 is 5. Cup 4 has 3 defects. 5 plus 3 is 8. And then these cups are fine, good to use. And then this cup has 3 defects. 8 plus 3 is 11. And finally, this cup has 1 defect. 11 plus 1 is 12. So out of the total 11 cups, there are 12 defects. Either the top is broken, or the bottom is broken, or the handle is broken. And in some cases, all the 3 are broken. So if somebody asks how many defects are there, you will count all the broken parts and say those are the defects. The next question is, how many cups have more than 2 defects? Different cups have defects in it. Some are very good to use, but there are few cups where there are more than 2 defects. It can be 3, 4, 5, 6, doesn't matter, but it's more than 2. So if you try to count that, you will get 3 cups. Which are those? Cup number 3 has 3 defects. Cup number 4 has 3 defects. And cup number 8 has 3 defects. So if I ask how many cups have more than 2 defects, it's 1, 2, and 3. So there are 3 cups which have more than 2 defects. The next question is, how many cups have only 1 defect? Just one. Either base is broken, or handle is broken, or top is broken. If you look at it, you will see that cup number 10 is the only cup which has only 1 defect, and that is the base of the cup is broken, right? So of the 11 cups, there is only 1 cup which has only 1 defect. There could be other cups which have more than 1. That's a separate question. But the question here is, how many cups have only 1 defect? The answer is 1. That is cup number 10. Now comes the key question. How many defective cups are there? So the definition of defective was anything which has 1 or more defects in it. It is called a defective product, right? So keeping that definition in mind, if I ask you how many defective cups are there, you have to find out those cups where there is 1 or more than 1 defect. So cup number 1 is defective. Cup number 3 and 4 are defectives because something or the other is broken. This cup is also broken or called as defective because 3 things are broken. And cup number 10 is also a defective cup because the base is broken. So if you count such damaged cups, you will get 1, 2, 3, 4, and 5. So to answer this question, how many defective cups are there? 5 cups are defective, or 5 cups are the ones which are damaged because something or the other is wrong with them. So out of 11 cups, 5 are the defective cups in them. So this is the foundation of understanding defects versus defectives. If this is strong and you know how to define defects, you will be able to use this in an extensive manner, not only in manufacturing, manufacturing, but in any sector for that matter. And I have an example of how do we try to use this in academics. It may not be something that you do on a regular basis, but you may want to experiment and see if that is going to make sense. Okay, so let's go to the next section and understand some of the concepts that comes under defects. Okay, the first thing that comes in defects is DPU, nothing but defects per unit. DPU stands for defects per unit. It is a method where we calculate number of defects in a product or a service. It is calculated by dividing defects by total units, divided by the defects divided by total units. Okay, so here I have tried to give an example from an academic standpoint, and I hope you people will be able to understand this. There are 4 students, Hari, Sudha, Pratap and Sumana. These are the number of questions that they have attempted in physics. Hari has attempted 15, Sudha has 14, Pratap attempted 13, and Sumana attempted 11 questions. Then of the number of questions which each one of them attempted, how many they have got correct? Hari got 12 questions attempted out of 15. He got 12 correct. Sudha attempted 14. She got 9. Pratap attempted 13. He got 12 correct. And Sumana, who had attempted 11, has got 8 correct. Which means the difference of this are the ones which they answered incorrectly. Like Hari answered 3 of them wrong. Sudha got 5 questions incorrect. Pratap got just 1 incorrect. And Sumana got 3 incorrect. Right? Now you have to calculate DPU, defects per unit. So what will be the defect here? Obviously the questions answered incorrectly are the defects. But how many units? Out of how many they have answered few questions incorrectly? That is nothing but the questions that they have attempted. Hari attempted 15, he got 3 of them wrong. Sudha attempted 14, she got 5 of them wrong. Pratap attempted 13, he got 1 question wrong. And Sumana attempted 11, she got 3 questions wrong. You need to see this variation. All of them have not attempted equal number of questions. And for the set of questions that they attempted, they have got few questions wrong. So my defects are available in this column, and my units, that is DPU, the unit, are available in this column. So if I divide 3 by 15 or 5 by 14 or 1 by 13 or 3 by 11, I will get my DPU. Have a look at the right hand column in green. 3 by 15 is nothing but defects by units, 0.20 for Hari. Similarly for Pratap, defects per unit, 1 by 13, 0.07. Sumana, 3 by 11, 0.27, right? But how do we infer this? Lesser the DPU, better is the performance. Lesser the DPU, better is the performance, right? Of the 4 students, whose DPU is the least? Pratap. Pratap has 0.07, correct? But he attempted only 13 questions. Hari attempted 15 questions. So do you think if Pratap had attempted 2 more questions, what is the probability that he would have got all the 2 wrong, or all the 2 right, or 1 right and 1 wrong? We don't know that at this point in time, right? But if you or your college feels that we will always select the student to pursue something new or in addition based on their DPU score, then Pratap is the winner, right? But if you say, I would prefer to look at that student who has scored high, who has attempted highest number of questions, but doesn't matter how many questions he got wrong, then DPU is not the right measure, right? So here, if you feel that you will go based on DPU score, then Pratap is the clear winner because he has attempted 13 questions and has got only one wrong. So 1 by 13 is 0.07. So this is how we take DPU. Okay. I will retain this slide for one more minute for you to look at it and understand and get your concept strong. Because if you understand the concept, then you will be able to apply it in your respective fields. Correct. Even in your college, I'm sure there will be a department to procure stationery and other items that is consumed in your college on a regular basis. Let's say you are ordering markers to write on the board, correct? And each month you may need about say 100 markers in the college for various classes. You will then say that if a marker is leaking at the time of buying it in the college, that will be called as a defective or a marker with a defect. Then out of 100, say 3 such markers have come with either broken cap or it is leaking or something else is wrong with that marker. So the number of units in that case will be 100 markers and 3 are wrong. So 3 by 100 is your DPU score, correct? And if the management says at no point in time we should have more than 1 marker out of 100 coming with defect, and in this case if you have 3 such defects, you will then ask the supplier to take all these markers back. That's how it happens in a manufacturing environment. You say, no, this lot of 100 markers not acceptable, I can't buy this. I had told you at the most I can accept 1 marker which is having a defect but not more than 1. Take it back. So you will return it. So that goal of 1 marker is given by the college management, saying don't buy from him if he is giving more than 1 marker which is having defect from every 100 markers that we buy. So in this example, we will return it back to that college, to the supplier, saying, sorry, we can't buy this. We told you not more than 1, and you have given me 3 markers which are broken, which are leaking. Take it back. Right? So DPU, first there has to be a goal from the management. Then we look at the actual data and see, is it within that goal or not? If it is yes, we accept. If not, we take appropriate action. Okay. So this is all about DPU. Now let's get into the next concept called DPO. Very similar to DPU, there will be slight variation here. DPO is nothing but defects per opportunity. This word is very important. It's a method where we calculate number of defects based on number of opportunities per unit. In the previous example, the opportunity was a question attempted from the physics subject. Either you can get it right or you can get it wrong. So 15 questions attempted by one student are 15 opportunities, either to get it right or get it wrong, correct? So in that fashion, there the opportunity was only 1. But in certain cases, we may have more than 1 opportunity. It could be 2, 5, 10, 20. It depends on what the management considers as an opportunity. In the example of pizza, what do we want? First of all, we want it on time. Second, we want it as per our instructions that we are given. It should be veg or non-vegetarian. Should there be extra cheese or not? Should the topping be with say paneer or mushroom? These all are the attributes that you are describing while giving the order. And you expect that all these attributes are met successfully, then only you will be a happy customer, right? So you are basically defining the opportunities. You are telling the pizza should come in 30 minutes. The crust of the pizza shouldn't be burnt. The ingredients should be based on what you have ordered. Like one would really not want to get a non-vegetarian pizza, whereas when you have placed an order for a vegetarian pizza, it will be a big blunder, right? The customer will be very unhappy. So those are the opportunities that you are defining. And you can have 1 opportunity or more than 1. It's purely based on the requirement of the business or of the customer, right? Let's look at an example here. How do we calculate DPO? DPO is nothing but number of defects divided by number of units multiplied by number of opportunities per unit. As I said in the pizza example, you have defined three opportunities: time, ingredients, and taste. Those are three opportunities per pizza. So if you are making 10 pizzas as a pizza manufacturing company, 10 into 3 becomes your denominator. On numerator, you will have number of defects. Let's look at this example. You will be able to understand what I'm trying to say. Again, the cup example comes back, where a cup manufacturer, in order to control the quality of cups manufacturing, has identified three opportunities in a cup, namely base of the cup, cup handle, and top of the cup as critical to quality. So there is a quality controller who has said at no point in time the base, the handle, and top of the cup should be damaged. It should be perfectly as per specification, as per design. If any of these parameters are found to be broken, then such a cup will be thrown away. Basically, it's a waste. We cannot sell it. Even if you take it to the shop, customers will not buy it, and they will say, this shop always keeps defective products. Let's not go there. They will tell 100 people and the business will go down. Word of mouth is a very powerful tool. You will believe your friends, relatives' words more than anybody else. If somebody says, oh, that shop, oh, horrible, all waste products. Most of the products have defects. They don't work. They are harmful for human consumption. You say this to one person, and that person will tell to another 5 people, and those 5 will tell to another 100. Business gone. The shopkeeper will have to shut down the shop, right? So here the cup manufacturer has said at no point in time the top, the base, and the handle of the cup should be broken. These are critical to quality. Customer will buy our cups only if these three things are proper, right? And if it is found to be broken, we will have to throw that cup. We can't take it to the shop to sell. Opportunities are there per unit or per cup. Based on the quality controller, he has identified three opportunities. This is 1, 2, 3, right? Opportunities per cup. So in total, how many opportunities would be there either to get it completely right or completely wrong? 3 opportunities into number of units. There are 5 cups, so there are 15 opportunities. Either all 15 will be good, or all 15 will be bad, or there will be value in the middle. Some are good, some are bad. Okay, either you can get all 15 right, or you can get all 15 wrong, or a value between these two extreme ends. Now let's apply this based on the data available here. Let's apply the formula. How many defects are there? You count the broken pieces. 1, 2, 3, 4, 5. So you get number of defects as 5. That is your numerator, number of defects, divided by number of units. How many units have been manufactured, or how many cups? 1, 2, 3, 4, 5. Into number of opportunities per unit or per cup. In this cup, 3 things can either go wrong or all can go right. Plus 3 here, the top, handle, and base. In that fashion, top, handle, and base for all 3 cups. So there are totally 15, 3 opportunities per cup, which makes it 15, right? So my answer will be 5 defects divided by 5 units multiplied by 3 opportunities per unit or per cup. So my DPO will be 0.333. Meaning to say, if I am making 5 cups, my defects per opportunity is 0.33. Now, what is the inference from this? Inference is very simple. Lesser this value indicates accurate process. For example, let us say this second cup did not have this defect. The base, the top was fine, the handle was fine. Then our defects would have been only 3 instead of 5. So when the numerator shrinks, this value also shrinks. For example, this would be 3 and this would be 15. 3 by 15 is lesser than 5 by 15. Don't you agree with that? Right? So the inference is lesser the DPO score, better or accurate is the process. If let us say there was no defects at all the cups were fine, the numerator would be 0, 0 by 15. That is a best case scenario for a business where it indicates that the process is working absolutely fine. No defects are coming out of it at all. Everything is working as per our wish. It would appear like a dream, but in reality, we don't live in such a perfect world. There will be defects here and there. We need to catch hold of them. We need to find out the root causes for those defects and take necessary actions in order to overcome those defects. Because as I said, we don't live in a perfect world. No matter how good the roads get constructed by the municipality or the PWD department, some roads within 6 months will start showing potholes. Some would take 2 years. The roads on the highways may take 5 years, but at some point in time there will be potholes which travelers don't like, right? So we need to keep an eye when those potholes will come. Find out why did the PWD engineer said, no sir, this road will last for 2 years and within 6 months we are seeing potholes. What happened? We need to find out. Did he use good materials, or did somebody commit some other mistake while laying the road? The foundation was not strong. We need to know. So that is analysis, right? But defects is something which will always be there. The only thing that we can ensure is lesser the number of defects, better is the health of the process. Okay, so this is how you calculate DPO, where first you need to define what all opportunities are there. Let's say tomorrow there is another the print that I make on the cup to be part of my opportunity. Then the number of opportunities would become 4. It won't remain 3, right? So it all depends upon the management, how they want to define opportunity. So in this example, we had 3 opportunities: the base, the top, and the handle of the cup. So that is why we took opportunities as 3. You can take 2, you can make 4, you can make it 5. It all depends on what the management considers as critical to quality. Critical to quality. When you board a government bus or a train, you would have certain expectations, right? The train should be clean. The toilets or the washrooms should be cleaned frequently. The food that we get in the train should be of good quality. Those are your expectations. Any one thing that goes wrong, you call it as defect. Oh, the food was horrible. What they gave. The rasam was only water with chili powder. We couldn't have it. You will say, no, don't travel in this route. Say Rani Chennamma Express or Gadak Solapur Express for that matter. Food is good, not at all good, horrible. Let's not have it, right? So that is how you expect something and then you measure. Is it meeting my expectation or is it not meeting my expectation, right? So that is what DPO is all about. Number of defects divided by number of units into number of opportunities per unit. Okay. Now the next concept is an extension of this, which is DPMO, defects per million opportunities, where Six Sigma is all about 6 standard deviations, right? Or what happens when we manufacture million products. Million is nothing but 10 lakhs, right? Because manufacturing or service providing is a continuous process. Units keep on getting manufactured. Like in college, your college or any college for that matter, hundreds and thousands of students have studied and passed out, right? It's a continuous process. As long as the institute continues to exist, students will come, study, excel, and move out to pursue their career outside the college, right? It's a continuous process. There will be teachers who will come, teach for years together, get retired and go. There will be thousands of students coming, learn, go out. As long as the institute is there, there is inputs, students, reference material, books. There is a process of learning, evaluation, and there's a process of exit where students go and pursue their career, they go and pursue their education, because it's a continuous process. We cannot just measure, say, for one semester, computer science engineering department students scored slightly less marks, and then we say, oh no, this is horrible, they don't teach good computer science at all in this college. That is not the way. We need to look at and aggregate data for a large period of time. This one small dip in mark could be a variation which has happened due to some particular cause. We will investigate. That's a different story. But just by looking at one semester's performance of a student or a set of students and inferring, saying that, oh no, they don't teach computer science good at all, because see, the students have scored less than 50. That is incorrect to do. And that is why in Six Sigma, we measure it for 1,000,000 opportunities for a large period of time. And then infer saying, on an average, this college has 80% students scoring more than 75 in all the subjects. And when they ask for how long have you looked at the data, we'll say for 10 years we looked at it, and this is what the college's performance is. That indicates the right measure rather than reacting to a small shift in marks from here to there. Okay, now let us understand, how do we use DPMO, defects per million opportunities? Okay, it is basically an extension of DPO, and you will get to see that very soon. What the DPO that we saw, DPMO is an extension of that. How do we calculate DPMO? First, we get to know the number of defects the way we saw in the previous screen. We then find out number of units. We multiply it by number of opportunities per unit. All this is very similar to DPO. Whatever you get based on this expression, multiply that by 1,000,000 or 10 lakhs. Whatever output you get here, number of defects divided by number of units into number of opportunities per unit, you multiply that by 1,000,000, which is nothing but 10 lakhs. That is what DPMO is all about. Okay, let's look at an example. The same cups I have brought forward, same defects, no difference at all. If it is the same cups, same defects, your DPO would be same. Number of defects are 5, cups are 5, opportunities are 3, due to which your DPMO will be 5 divided by 15 into 10 lakhs, which is 3,30,000. There you had got 0.33. Because I multiplied that by 10 lakhs, I'm getting 3,30,000. Now, what is this trying to tell us? What it means is, the inference is very important, right? Calculation methodology we can by heart and understand, but we have to infer. Here we have manufactured 5 cups at this rate of getting defects. Okay, if I make 5,000 cups, what would be my quality score? So when I say 5,000 cups, what will happen? Number of units will go from 5 to 5,000, and then opportunities being constant, 5,000 into 3 will be 15,000. And as I continue to make more cups, my defects also will go up. So it is going to project, saying that if you make some thousands of cups, 3,30,000 could be your defects or broken pieces, or the something or the other would be going wrong. 3,30,000 could be your errors or mistakes that might happen if you are going to manufacture these cups on a consistent basis. That is what the inference is, right? So DPMO is nothing but an extension of DPO, where the output of the DPO, that what we get, we multiply it by 10 lakhs, or known as 1,000,000, and get a score which will tell. Let's say you're running a factory of making cups. Your management has said DPMO should never be more than 1 lakh. Okay, for the 5 cups that you made today, you got 5 defects, because of which your DPMO is 3,30,000, which means 2,30,000 more than the goal given by the management. Your management said 1 lakh or below, nothing more than 1 lakh. If it is more than 1 lakh, there is something wrong with our process. Something is happening. Either people are not paying attention while making cups, or the machine is not working properly, or the raw material that we put to make cups is incorrect, or there is some power fluctuation which is causing the machine to behave in a weird manner. Something is wrong. We don't know. But to know whether there is something going wrong or not, what is my indicator? The DPMO score. Right, the DPMO is 3,30,000, management said 1 lakh or below. Then we get into a Six Sigma project mode. We collect data, we pick up each and every cup which were found with defects and find out how many cups handles were broken, for how many cups the top was broken, for how many cups the base was broken, and how many cups all the 3 were broken. Then we collect the data. After collecting the data, then we find out what could be the reason why the handle broke. What made the handle broke? Then probably we'll find out that the person making those cups is not keeping it properly or safely in a place. He's just throwing it, because of which the handles are getting broken, or the raw material supplied is of poor quality, and because of which it is not able to withstand the heat that is used while manufacturing the cup, and because of that when it comes out it just breaks. These are reasons that you discover when you collect the data, when you analyze it, you discover. But to know whether the process is working properly or not, there has to be a measure, right? Let's say in your academics you decide that this year none of the students should score less than 50 out of 100 in any of the subject. That's a, let's say, management directive. Okay, all teachers, all of you will put all the efforts needed to ensure that all the students score 50 or more. Theoretically it might be possible, but practically some students will score less than 50. Let's say there are 5 students who have scored 48, 49, 47, which is less than 50. That becomes the area of study. You'll pick up those students and find out what happened. Why did these students score less? You will find out that out of those students, few had not attended classes regularly because of some medical emergency or due to COVID situation, whatever, right? And for some students, they are not able to grasp the concept. They are not able to understand some of the chapters. You get all these causes coming out of it. Then each of the cause you will start addressing. Why? Why is this student not able to understand this chapter? Thermodynamics. Let's take an example. Why are they not able to understand? You then do that root cause analysis and you get to know the actual reason. In that way, to know where the action needs to be taken, there has to be a baseline. And the baseline is given by the management. In the examples of the cups, the management said DPMO score should be 1 lakh or below, nothing above. Now here DPMO score is 3,30,000, time to take action. The quality controller will then initiate a Six Sigma project, collect the data, find the root cause, fix them, and sustain it. That is what Six Sigma is all about. For those who are getting exposed to Six Sigma freshly, you might take some time to get these concepts and understand it, but it is only through regular practice, one is able to understand and use Six Sigma concepts on a daily basis. And as I said, although this originated in the world of manufacturing, my experience over the last 15 years says that it can be applied anywhere for that matter, be it academics, healthcare, hospitality, transport, supply chain, retail, you name the sector, you can apply this as a concept. But the most important thing is people who practice this should be in a position to understand the concept thoroughly. Then only you can convince others to allow application of this in your respective institutions, right? If you are strong enough, then the management will get convinced saying, okay, let's try this out and see how well we are doing. right? So that is what I have tried to explain through defects. And now let us move from defects to another term which is very simple, called as proportion defectives, or in other words, defectives. Now, what is proportion defectives? It is a very simple percentage value. How is it calculated? We divide the number of defective units by total number of units multiplied by 100 to get a percentage, right? Very simple. I'll bring back that cup example. There are 11 cups, and based on the definition of defective, I had said earlier, any product which has one or more defects is called as a defective cup. A cup which has one or more defects is a defective cup, right? So here, of the 11 cups, there are, how many cups have one or more defects? Cup number 1 has 2 defects, so this is a defective cup. Cup number 3 has 3 defects. This is also a defective cup. This cup also has 3 defects. It's a defective cup. These 3 cups are fine, good for human consumption. Then this cup unfortunately also has 3 defects. It is a defective cup. And cup number 10 has 1 defect, but still it is called as a defective cup. So if I have to count how many defective cups I have, it would be 1, 2, 3, 4, 5. These are defective cups. I'm not counting defects. I'm counting defective cups. And what is defective cup? Any cup which has 1 or more defects is called as a defective cup, right? So we have 5 defective cups out of the 11 cups that we made. We made 11 cups. 5 of them are defective because of 1 or more defects in them, right? So we have to calculate the proportion. Very simple. Number of defective cups 5, total number of cups 11. You divide 5 by 11 and multiply it by 100. 45.45% of the cups made today are defective cups. Yeah. Mute my video. You might. Which video, madam? You mean you don't want me to be visible? Okay. How is it now? Hello? Madam, can you hear me? Okay. Okay, fine. So proportion defectives, as I said, we find out how many defective products are there, whether there is 1 defect or 3 defects. It's a defective cup. It cannot be used for human consumption. People will not buy it, right? So we count such cups: 1, 2, 3, 4, 5. So there are 5 cups which has 1 or more defects, and therefore they are called as defective cups of the 11. So of the 11 cups that we made today, 5 have been found to be defective. So 5 by 11 into 100, we get 45.45%, meaning to say of the 11 cups that we made, 45% of them were defective. Only 55 of them, or 55% of them, are the ones which can now go to the retail outlet for sale. The remaining 45% will have to be scrapped. That's a huge loss, right? Almost half of the cups made today are unfit for human consumption. So what can we do? Nothing. We have to just scrap it and find out what happened. Why so many cups had defects? What happened with the process? Is it a problem of people who are not handling it properly? Is it the problem with the raw material that was used today? Is it the problem of the machines? Or is it the problem of the power fluctuation where all of a sudden high voltage came in and something went wrong with the machine, due to which the cups got damaged? What happened? That investigation is nothing but a Six Sigma project where we collect data, we analyze the root causes, we find out what caused the problem, we fix it and ensure that the solution is sustained for a long period of time. This is proportion defectives. Okay. And with that, we are coming towards the end of the session. Let me quickly give a recap of what we learned in the second half of the session after the break. We first understood what discrete data means. And within discrete data, we saw defects and defectives. In defects, we covered defective cups, defects per unit in opportunity sigma project. It's all about data. I hope I have made these concepts clear for you guys to understand. After this session, as I have told Chaya madam that I will be sharing this document with her so that she can forward it to all the participants who have attended the session today. And apart from that, I will be sharing my email ID as well with her. So any one of you who have any doubts regarding the concept, please feel free to mail me and ask your questions, and I will try my level best to clarify those doubts based on my knowledge and my experience. For me personally, this has been a wonderful opportunity to conduct a session of this in nature. In fact, I have been doing such sessions in some of the colleges here in Bangalore by being physically present in those colleges. But this is for the first time where I'm doing a virtual session for people who are, far away there in Bagalkot and other places around that district. So I would like to thank all of you for your time and energy and making it to this session and learning from this, because it's not only a learning for you, it is also a learning for me. The more I talk about such concepts, I become more confident. My concepts become stronger, more than what it was earlier, and thereby we learn collectively. That is the core principle. Learning should always be collective and not in a silos or in an isolated manner. So thank you, Chaya madam, and thank you others from the college management for providing me this opportunity today. And I hope I have tried to put these concepts in a simple and a clear manner for you guys to understand what measurement techniques and data is all about in the journey of Six Sigma. Thank you so much.
Sir, there are a couple of questions.
Yes.
Which method is the best for meteorological data when it is non-normal?
When you say meteorological data, what kind of data is it? If I can get an example.
It is related to amount of rain or wind flow or pressure in the environment.
Right. So you mentioned non-normal. I have not covered that concept here, but normality test is a test that we do on continuous data to see if it is coming from normal distribution, right? So if the data is not following the normal distribution, then we usually go with median, because when we say a data is non-normal, it means to say that there are too many outliers. Because of that, we use median.
Yes, sir. One more question. How data is different from information?
The analysis that we do, data is always in a raw manner. Let me give an example. Let us say that, okay, let me give an example from the present situation itself. At an aggregate level, uh, across India, we have about 250,000 active COVID cases. This is data. And we are talking about a country like India. I'm just saying 250,000 active cases across India. This is data. Now, when you go into the data and find out, is it equally distributed across India, or are there only pocket areas in India like Mumbai, Delhi, Chennai, Ahmedabad? When you go into the data and find out, okay, out of 250, where are the majority of active cases? You will then find out that Delhi has 25,000 active cases, Mumbai has 27,000 active cases, Chennai has 33,000 active cases. You infer from it. You draw that inference, saying, although it is 2 lakh 50 across India, more than 1 lakh are there only in 2 to 3 cities. That is information.
Okay. Sir, one more question. What is industrial standards for DPO? I understood that it should be as low as possible, but permissible limits.
There is no standard as such. It all depends upon the capability of the process and the management's decision, right? Say, let us say, let me try to give an academic example. Okay, let us say a particular city. Okay, they have just started. For them to say that we would score average 95 in 10 standard, or we will get 90% minimum for all the students, there is no historical performance. We don't know how well the scores will come out over a period of time. But after having run that school for 5 years, 6 years, or 7 years, we will know how our students are doing, how well they are able to understand what the teachers are teaching. That will tell us, that will give us a confidence saying, maybe our first batch of 10 standard students this year will be able to score 85% for sure. And let's say they end up scoring 85, then 85 becomes your base because the first batch scored 85%. Then you will try to target higher. Let us try 90% for all the students in the coming year, because we have already hit 85 and we know what we need to do to reach 90, right? So there is no specific standard as such. It depends on the process capability. In Six Sigma, there is a concept called process capability. That is how capable the process is to deliver a target. In this example, 90% for all the students. How capable are we? Do we have that infrastructure? Do we have those kind of students? Do we have those extra facilities needed, like extra coaching, extended hours, interaction with the different kind of teachers to understand the concepts? Do we have those facilities? Those are known as capabilities. So in Six Sigma, we do something called as process capability analysis. And that analysis tells us whether, if we set a goal of 90%, whether we'll be able to meet it or not. Or in this example, if I set a DPO goal of 0.15, will I be able to meet or not? The capability analysis will tell us.
Okay, thank you, sir.
Yeah.
On behalf of coordinators and Basaveshwara Engineering College, I wholeheartedly thank today's speaker, Prashant Kamath, for sparing his valuable time in spite of his busy schedule and making the informative session for us, all of us. Thank you, sir. Thank you, participants.
Thank you so much, madam. And I wish all the participants the very best for their career that they are pursuing. And I hope this session has added on to the knowledge that they already have. So I wish them the very best. Stay safe, stay healthy with your families and friends. And let's all come out of the situation as soon as possible. Thank you so much.